This is Mr. Bo, and we're going to talk about how to do union and intersection, complement and difference today. This is kind of a review. We've been doing it in class, so most of us should be familiar, but this is a little bit of a review for us. So the first thing I want to talk about is union, and union has, let me get up my, hold on, there we go. Let me get up my note-taking here. So union has this U-looking thing up over here. It's easy to remember that it's union. And sometimes we say or for this, and that's really connected to logic. Wait, but that was really ugly. That was also really ugly. I'm having trouble today with my pen. So logic, we have kind of that symbol over there. That means or. So a union is defined as, you can see, X such that X is an element of A, or X is an element of B. So X is in A or in B. So if this is set A and this is set B, then the union is all this red stuff inside here. Okay? If there are three sets, A, B, and C, then it's all of this red stuff in here. It's every A union B union C is everything in those three. Okay. Our intersection, on the other hand, has this kind of upside down U, and sometimes we call that and, because it's X such that X is an element of A and X is an element of B. So when we study logic later, we'll have that symbol, and they look really similar. Looks really similar to the upside down U here for intersection. So we can call this and easily, in easy English. And then when we move into logic, we can think of it as and too. So it's in A and B. So if over here this is our A and this is our B, then everything that's in A and B is the intersection. If we have three, this is A, B, and C, A intersection of A and B, and the intersection of C is the stuff that's in all three. Here's an example of an intersection. So we want to find, again, see that intersection. We want to find everything that's in A and in B. So it's the same stuff. So I can see this pentagon, orange pentagon, is in A and B, and I can see this green square is in both A and B, but this diamond is in A but not in B. This rectangle is in A but not in B. This triangle is in B but not in A. And this star is in B but not in A. So the resulting set that we get from A intersect B is the things that are in both A and B, and that's this orange pentagon and this green square. Our complement, whoops, move forward a little bit here. Our complement has two ways to talk about it. One is this C over here, and this is actually the more common one, but it's not the one I'm using in my class. And the second one is a little line up at the top there, and that's less common, but the reason I'm using it is because we're going to study logic next, and in logic that's called not. So you'll see both the C and that line. But basically it means X is an element of our universe, but X is not an element of our set. So X is an element of the universe, but X is not an element of the set. So that's why I like that not notation, because it's not A, and sometimes we just get really lazy and say not A. So if this is A, then A naught, or whoops, complement of A is all the stuff that's not in A. And that's true even if we have two sets. So if this is A, then this is all the stuff that's not in A. So we don't need to really worry about what's in B. Okay. All right, the last thing that we're going to talk about is our difference. And in our difference, there are, again, two ways to talk about it. And, wow, this is really screwed up here. Hold on a second. Okay, so there are two different ways to mark it, and this one is probably more common, and it's a backslash, and it means difference. But I'm also using this in our course too, because it looks like a minus sign, and minus sign is difference, so that makes sense. Some people say it's ambiguous, but I don't really think it's ambiguous. But this is the X is an element of B, and such that X is not an element of A. So it's everything that's in B that's also not in A. So if this is A and this is B, then this red part in here is everything that's in B that's not in A. Everything in B that's not in A. So we have to cut out the intersection. All right, so we have to cut out the intersection, and that's kind of an easy way to think about it. You just find the intersection, and then you wipe that out. So that's the difference. So that's B minus A. It's this set B. Originally, that set B was everything in here, right? But then we cut out all the stuff that's in A. And so that means that we're left with that stuff over there. Okay. All right, so we're going to do a little bit of practice here. So my universe is the English alphabet, so there are 26 letters up here. And over here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have 20, so I have 6 that are not in here. I have to figure out what those are, and I'm going to list those out in the universe. And that's the first thing that actually that's number 1, but we'll figure that out in a second. So I've got A, I don't have B. I have C. I don't have D. I have E. You can help me look. F. G. H. I. J. K. I don't see an L. There's the L. M. N. O. P. Q. I don't see an R. I don't see an S. T. U, V. I don't see a W. X, Y. This should be it. Z. Okay, so 1, 2, 3, 4, 5, 6. So I've got them all. So I have 20 in sets A, B, and C, and I have 6 outside that are not in set A, B, and C. So the first thing I want to do is I want to look at A union B union C, and if we go back and we look at union of 3 sets, we'll see that's everything that's in any of those. And then over here I have this not. We got an autocorrect there. I don't know. It should be a line like every other one. So that the stuff that's not in A union B union C, the complement of that is this stuff over here. So that's going to be B, D, F, R, S, and W. All right, next I have C not, the complement of C, intersect with the complement of A. So I'm going to use red here to find the complement of C. So here's C. And here's the complement of C. Everything out there, all that red stuff is the complement of C. And I'm going to use yellow for A. Hope that shows up. Let's try green instead. So the complement of A naught, is everything that's not in A. So that's all this stuff over here. And we have to look at the circle that's A. Okay. All right, so now we want the intersection. Intersection means that remember the complement of C is red and the complement of A is green, so we want everything that is both red and green. We want all the areas that are both red and green. So we have this B, D, F, R, S, W. And I also have T and I up over here. Okay, so this part is only red, and this part is only green, and this part is nothing, right? So, and I also have T and N and I. Okay. All right. My next question. I'm going to skip ahead to 4 here. And clear out my writing a little bit so everybody can see. All right, so we're going to skip ahead to 4. Not A, complement of A minus complement of C. So again, we're going to find the complement of A, and I'll make that green. Complement of A minus the complement of C, and C I'm going to put in blue. Complement of C so remember that this complement of A minus complement of C means everything that is in the complement of A that is not in the complement of C. So complement of A is green. So we want all the green that is not blue. And I can see that over here. This is the green part that is not blue, right over here. So that is E, G, M, X, J, H, and V. Okay. So that pretty much covers everything that we need to do with union and intersection and difference. I hope that cleared it up for a lot of people.